Hey you, welcome back to all of you again once again on your channel, that is on JEE Physics. So this is 2026 JEE Advanced paper 1 question number 2. Let us solve it, and the process will be same as we have solved question number 1. We will try to figure out every single possibilities that we can discuss around the question, so that the idea is to weapon you up with enough tricks and techniques and concepts so that you can solve the question on your own. Again, my humble suggestion, before going towards the solution, pause the screen, try the question out on your own. If you fail or if you stuck somewhere, then only refer the solution. Otherwise, do not refer to the solution. देखो, so in this question they are mentioning that there is a circuit consisting of capacitance C, coil N turns per unit length, cross-sectional area S and length D, where D square is much greater than S. Fine. There is another coil of length D by 2, cross-sectional area S by 2, 2N turns per unit length completely inside. So there is one coil inside another coil. So it's a classical example of coaxial coils. The ends of the smaller coil are connected with each other by an insulated conducting wire. This is very significant. This line is very significant. What is the significance of this line? When they are saying that means this is short circuited. This is short circuited. And they are not mentioning about the resistance of the wire, so we will consider this to be a live wire. So for the live wire, we know resistance is equal to 0, so potential drop around that will also be equal to 0. It will act like a superconducting coil. I will be using that particular concept of superconducting coil in one of the methods of the solution, so please stay tuned. Let us proceed. Self-inductance of the larger coil is said to be L, neglecting the edge effects and all ohmic resistances. Resonant frequency of the circuit is okay. So first we will see solution 1, that is method 1. Method 1 is the most simple basic solution we will learn from the very basic. What is that? That we know, if I talk about the circuit, so here I will assume that, let us say, I1 current is coming to the circuit. Here I1 current is entering, and here due to back EMF 1 current I2 is flowing in the circuit. So the bigger one is basically my first one loop, and this inner one I call it second one. So now if I proceed with the solution, so first I will write phi 1 is equal to, what can I write? L1 I1 minus M into I2. Now let us calculate this L1. How will I calculate L1? So you please see, I can write L1 I1, that is equal to magnetic field. This is equal to mu naught N into I1 into flux. Basically here I am talking about total flux. So that into number of turns per unit length is N, total length is D. So total number of coils, a number of turns will be N into D, and surface area of cross section here is S. So there I1 gets cancelled. L1 is equal to, you get mu naught N square D into S, and that is given to be L. So this is the value of L that we got. Pretty clear? There is no doubt whatsoever, right? Exactly in the same way, I can calculate the value of L2. So what will I write? L2 I2 is equal to mu naught 2N I2 into 2N. This is length D by 2 as mentioned in the question. And the surface area is also equal to how much? S by 2. So this 2 cancels out, this 2 cancels out, I2 cancels out, L2 is also coming, mu naught N square D into S, which is also equal to L. So L1, L2 value came to be same, right? I will be using this latter. So hold on for some time over here. Now phi 1 is equal to this much we got. So if I differentiate this, so I can write d phi 1 dt is equal to L1 di1 dt minus M di2 dt. So what I will do, I will take this equation as equation number 1. This is my equation number 1 for loop 1, for the bigger one. If I apply the same logic for the smaller one, what will come? Phi 2, so this is for the bigger one. For the smaller one, phi 2, we can write L2 I2 minus M I2. Okay. Now here the point comes, which is, you see here, the moment I will differentiate d phi 2 dt is equal to L2 di2 dt minus m di2 dt. As I said, here d phi 2 dt will be equal to 0. There is no resistance, there is no potential drop for the smaller one. So here di2 dt, it becomes, the result is becoming, we can write L2 by m. Sorry, there is, I think there is one calculation mistake we have done. This has to be I1 because we are talking about mutual inductance. So this has to be I1. So this is m into I1, m di1 dt. So di2 dt becomes m by L2. So it is becoming m by L2 di1 dt. Right? So this is the equation number 2 that we got. Right. So this is my equation number 2. Now I will go back to equation number 1 once again. So if I go back to equation number 1, so I'm writing from 1. From 1, what will I get? I will get d phi 1 by dt is equal to L1. If I substitute the value of di2 by dt in this equation, I will substitute the value of di2 by dt in this equation. So L1 minus m square by L2 into di1 by dt. Now this equation presumably comes d phi 1 dt is equal to nothing but minus q by c, that is equal to L1 minus m square by L2 into di1 by dt. So here this equation is clearly referring the equation of SHM, where I can write omega square is equal to L1 minus m square by L2. So here in this, directly I can write L equivalent. L equivalent is this quantity, that is equal to L1 minus m square by L2. L1 we already got L minus m square. L2 also we got L. Now regarding calculation of m is easier. We can do mu naught n into I1, that is the magnetic field. I have to calculate through the smaller one. So 2n into d by 2 into s by 2 whole divided by I1. So I1 cancel. These two cancels. 1, 2 is surviving. So it is coming L by 2. So if I replace this, this is becoming 3/4 of L. So once 3/4 of L, omega is equal to, we know, 1 by under root of L equivalent into C. So 1 by under root of 3L by 4 into C, and hence the result is coming 2L. Here only 2 is coming up, divided by under root of 3L into C. So that's the answer of this question. So yeah, we are going for option C. Now there is another way of looking into the same question. How can I cut it short? So now we are going for method 2. Method 2 is directly we will employ this. So for two coaxial cables, L equivalent, you can directly use the formula, that is equal to L1 into L2 minus of m square divided by L1 plus L2 minus of 2m. Very useful formula, and if you use this formula, this question will be really cut short. Now look, L1 we got L, L2 also we got L, m is equal to L by 2, so that becomes L square by 4. Sorry, this is multiplication over here, divided by L1 plus L2 becomes 2L minus of 2 into L by 2. So here also it becomes 3L by 4. Once you get this is 3L by 4, omega is equal to, as I have said, 1 by under root of L equivalent into C. So the answer becomes 2 by under root of 3LC. That's how this is useful. If you can remember this formula, then it will really make your job very easy. Correct? So this is our method 2. Now coming back to method 3. Here we will cut the time as well as we will employ a very deep rooting concept of flux conservation. As I told you already, this is smaller coil, this particular circuit, if I redraw this one, this smaller one is connected by a live wire. So this is behaving like a superconducting coil. So this is behaving like a superconducting coil. So since it is behaving like a superconducting coil, so here I can assume when the current was 0, flux initial was equal to 0. So flux final will also be equal to 0 through the smaller one, through the smaller coil. Now I will be employing this concept over here. How can I do it? Then if I look at the rest of the system, for the rest of the system, if I have to draw the diagram, so let us say this is the bigger coil we are talking about. This is the bigger coil we are talking about. In the bigger coil, so there is a very small portion of the smaller coil, this portion here we are talking about. So please understand that through this smaller domain, this particular domain, flux will remain 0. So then the flux will be passing to the remaining portion. So for the remaining portion, flux remaining will be equal to how much? Flux remaining will be equal to, if let us say I1 current is passing through it, which we have already assumed, then we can write it is the volume they have given is 1/4. This volume is 1/4 because if you take this is here cross-sectional area was S by 2 and the length is also D by 2. So here the volume becomes how much? Volume becomes S into D divided by 4. So this smaller volume is actually S into D by 1/4 of the original volume. So the remaining portion volume will be 1 minus 1 by 4 L into I1. So this becomes 3L by 4 into I1. Now phi remaining, if I want to point out as L equivalent into I1 is equal to 3L by 4 into I1. So directly by using the conceptual analysis, you will get L equivalent is equal to 3L by 4. So once you get L equivalent equal to 3L by 4, the job is easy. Omega equal to under root of L equivalent into C, and hence your answer becomes 2 by under root of 3L into C. I hope you have enjoyed, and if you have enjoyed this, hit the like button, do share and subscribe. Thank you. See you in the next video.